In today's lesson, we're going to be looking at exercise 8C from the Year 12 textbook, Modelling Linear Growth and Decay. So when a quantity increases or decreases by the same amount over regular intervals of time, we have what's called linear growth or decay. In previous chapters with financial mathematics, we've looked at simple interest and depreciation, and they're both really good examples of linear growth and decay respectively, okay? Remember from our previous exercise that recurrence relations always have the form V0 equals A, so that's just your initial term or value, where Vn plus 1, so the next term in the sequence is given by the current term Vn plus D, whatever the difference may be. D here is going to be positive if you have growth, and you'll have minus D, so a negative value for D if decay is occurring. We'll jump straight in with an example to better represent this. So Lucy's simple interest is modeled by V0 equals 4,000 and Vn plus 1 equals Vn plus 360. Okay, so from this we can determine what the principal is just by reading the recurrence relation. Okay, the principal in any financial situation is what you begin with. So the principal will always be V0. $4,000. You'll just need to make sure that you put your units in your answer, okay? Whenever we talk finance, we should have a dollar sign out the front. For part B, what is the interest? We can also look at the recurrence relation and decide what that is, okay? So the interest is how much the account earns. In this case, D is positive, okay? So we're earning $360 per annum, okay? We're assuming per annum because interest is usually, or any financial situation, we're assuming years, okay? Also, $360 would be far too much to be earning in less time than that, so we're going to assume per annum, okay? What will be the value of the investment after 3 years? And this kind of confirms as well that we're looking at per annum. So we look at V1 equals 4,000, so the initial value, or the current term, plus the difference, 360, and we get $4,360. V2, we're going to add the difference, so again, 360 to the last term in the sequence. So 4,360 plus 360 gives us $4,720. Finally, the answer we're looking for, V3, so the value of the investment, V after 3 years, is 4,720 plus 360, which gives us 5,080. You're of course welcome to use a calculator. When you do this, just type in the first value, so 4,000, hit enter, and then literally type in plus 360, enter, 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 and that will give you your V3 value. Finally, part D, when will Lucy's investment first exceed $6,000? So we'll continue on with the sequence until we hit that $6,000 as a minimum. So V4, 4,720, that's a funny looking 5,080, sorry, I've read the wrong numbers. Okay, so we're taking still the last number, 5,080 plus 360. Gives us 5,440. You can do that in your head or in your calculator. I do not mind. V5 equals 5,440 plus 360. Okay, and that equals 5,800. And finally, I don't know if I'll be able to write it. Oh, I can just fit it in. Cool. Equals 5,800 plus 360. And that gives us 6,160. So Lucy's investment will first exceed $6,000 after 6 years. Okay, and that's your final answer. You could write Lucy's investment will first exceed $6,000 after 6 years. I'm going to run out of room because I have a few more points for you. So a couple of notes, just definitions that you'll encounter through this exercise. Unit cost depreciation occurs with use over time. So for example, the more you drive a car, the more it will decrease in value over time. You could own a car for 5 years and drive 25,000 Ks and it will retain most of its value. However, you could buy a brand new car and drive 100,000 Ks in 5 years. The person who drives 25,000 kilometers will be able to sell their car for a lot more than the person who drives 100,000 kilometers in the same amount of time. Okay. Flat rate depreciation occurs as a fixed percentage over time. So instead of looking at how much something is used, we're looking at for every year that, well, I'm just going to keep using cars as an example, even though it's not quite relevant for this one. So every year that the car is owned and driven, it will decrease by a certain amount of its initial value, so the amount that you purchased it for. Okay, obviously cars will run with unit cost depreciation. Flat rate depreciation might occur for something else altogether. And finally, scrap value is when the item is considered no longer useful. So literally, if you think of a car, its scrap value might be $1,500. So at that point, you would probably earn that amount of cash if you took it to a scrap dealership and literally sold your car for parts, rather than trading it in for next to nothing at a dealership to then purchase your new car. So scrap value is when the item is considered no longer useful and should be scrapped. And that's all for exercise 8C. As always, if you have any questions, feel free to contact me, and I hope to see you all on a conference call very soon. Good luck with the work, guys.